We're looking at complex fractions and complex numbers. All right, a complex fraction is just a fraction that contains more than one fraction. Has more than one fraction bar. Or it has either a fraction in its numerator or its denominator. Anytime you have a complex fraction, you have to simplify it. Do not give me a complex fraction for your actual answer. Something like that is a complex fraction. You can't leave your answer like that. Does that make sense? Or something like that. Anytime it has more than one fraction bar, it's a complex fraction. Does that make sense? So something like this. If you think you can do it by yourself, go ahead. If you need help with these, I'm going to go over it. Do what? Wait, what did you say? Probably. It was like 20 something this morning. Okay. Any ideas what you would do? Okay. So what would the numerator become? Over b, right? And then ab stays the same. Now what do you do? Uh-huh. Good job that you figured it out. Right? Same? No, this is not that thing. Does that make sense? Do y'all see how that works? Any questions there? Did y'all get that by yourself? Okay. What's different about this one? You add to. You have a complex fraction and then you have to add something to it.
It looks so big at the bottom.
Like this is a over x and then plus 4 and then all of that is the denominator. If you think you can do it, go ahead. Okay, if you want to try. Okay. You want to leave the a over x alone for now, okay? Because it's already just a fraction. What do I need to do with this second one? That's right. How do we make this not a complex fraction? We say 4 times what? Which is what? Does that make sense? Any questions there? Okay. On this part, going from here to here, you say this one times the reciprocal. So you flip it and make it x over x plus b. You've got a fraction divided by a fraction. So you say fraction times the reciprocal.
Okay, now we do.
Does that make sense? So now we have two fractions. How do you add two fractions? What is the common denominator? X times x plus b. So what do we multiply the a by? And what do we multiply 4x by? If you leave it like that, that's fine. They distributed the a. If you want to distribute it, it's fine.
That's the answer?
No, you don't have to. Unless you think that some terms are going to combine, just leave it. Any questions? Like if this was x times x, you could add it to that one. Does that make sense?
You get X plus B.
1 times x is x. The b already has an x as a denominator, so you don't have to multiply it by anything. You look at this part. You made that.
I know what you talk about. Fixed numbers are the improper fraction.
Yeah, no, that's not what it is. It's just because it's a 1. It's just like changing these into one fraction. The common denominator is an x. The 1 needs to be... Okay. Any other questions on these? Okay. All right, looking at complex numbers. There's a real part, which is the a, and an imaginary part, the bi. No? Remember complex numbers before the break? A plus bi. A is the real part, and bi is the imaginary part. Together they make the complex number. That's the way you write it. A plus bi. That's the form. You always want to write it in this form. A plus bi. It's just your imaginary number.
So the B is
It's just a number. Yeah.
Oh, so it's saying like 1 plus 2i.
Yes. Yeah. Does that make sense?
You need 4 and then like, oh yeah, that's
Examples of complex numbers. 2i minus 4 plus 3i. Is that in standard form? What would you write it as? Right? For 7, is there an imaginary part on this one? So do you need to put plus 0i? No, you just leave it as 7. Does that make sense? Is this one a complex number? Yeah, its real part is 0. But do you need to put 0 plus 1/2 I? No. If it's not there, you don't have to put it. Is this one a complex number? Is it in standard form already? Yes. It's still considered a complex number. Yeah. It's just 1/2. Yeah. That's how the smartboard does fractions. Yeah, you've had ones like this already. All right, looking at one like this. Do you remember how to write that as a complex number?
Square root of 2i, square root of 3i.
What happens to the negative? It becomes an I. So you have square root of 2, I, and then what?
Square root of 3i.
Are these two being multiplied or added? So what is square root of 2 times square root of 3? I times I is I squared. Does that make sense? What is I squared? Do you remember? So the square root of 6 times -1 is negative square root of 6. Y'all remember doing things like this? Because it's just by -1, so you normally put the negative in front. Yeah. Okay? Do you remember ones like this?
What's the same thing? It's just we haven't had it.
Yeah. Okay, so see if you can do one like this. What?
Do I read that, add that on to the end?
What do you mean? What part? They all end up as numbers. They all end up as numbers.
Like, they're not like a number, but it's square root.
There aren't any square roots when you actually get your answer.
Well, you just said it was -1 square root. Is that what you phrased?
For that one,
Right.
that's not the same thing.
Right, so it's multiplying I feel like
What do you do with the 4i cubed? -4i. Any questions on that part? Okay, what about -2i to the 4th? -2. What about this part? You're going to say 2 times what? Square root of 9i. Does that make sense? Yes. We'll get there. What happens here? And then another square root of 3i. Any questions so far? Okay, so -4i minus 2. What happens to the square root of 9? 3 times 2. Any questions with that part? Okay. What happens over here? Huh? 3. Any questions getting the 3i squared? 3 times 3 is 9, so you have the square root of 9, which is just 3. And then I times I is I squared. Any other questions there? Okay. Negative 4 plus 6. And what happens to the 3i squared? So I get 2i minus 5. Is that how I'm supposed to write my answer? Okay. Negative 5 plus 2i. If you put your answer as this, from now on it will be marked wrong. You always have to put them in standard form. Does that make sense? The I always goes at the end. Any questions on these? Okay, looking at another one. See if you can, yeah. See if you can try this one. Does someone want to go work it out on the board? Okay, go ahead, Jamar. Do you agree with him? Do I need to go over that one? Any questions here? Okay. Nope, that's it.